working on a project where setting performance learning preprocessors and support for multi-target compilers. But first, how is it going today in Cabal? I think preprocessors plug in for Cabal, the user attribute grammar system. What you have to do is create a custom setup file, write an additional file for the attribute grammar options, and specify all your options. So that's how you use this plugin. But there are some issues with it. You have to create additional files for it to work, and it's not compositional. What if I wanted to use another plugin? I have no idea how to combine those. So what I did in Cabal is specify directly preprocessing inside the package description. Just write down which preprocessor you want to use, how it compiles it with flags. And the other two multi-targets, you can of course build twice for different targets. But you have to manually ensure the two builds don't collide and don't override files. And here I built a different directory, of course. But it would be a lot better if just in Cabal I just allow multiple targets to be specified in the command line and to build them all at once. Okay, Cabal is a complete redesign from scratch of the Cabal build system. The main focus lies on improved dealing with preprocessors plugins in multi. And for building, it actually uses Shake library. We'll go into detail later. Okay, first an example of how the package file looks in Cabal. Just specifies a name, a library. You have a special section called tool, which is on local preprocessor. And that's how you specify local plugins, if you want them. Okay, it has some simple command line arguments for specifying which compiler, the flag to specify actually which target you want to build. You can use multiple of them and build the cross product of target and flavor. And you can pass options directly to Shake for controlling how many cores it should run on, velocity, and a lot of some other Shake stuff. Okay, the system works based on a system of nested classes or superclasses, which specifies the level of abstraction for the external tool you want to use. You have a tool. I will get into detail now later on. Okay, I used the Shake build system as I just said. It's especially helpful because it allows dynamic dependencies. For example, you want to compile a Haskell file to an object file. You need the Haskell file, of course, but you also need the indirect dependencies, the imports, the interface files of the imports. If the Haskell file is generated, there is no way I could upfront come up with which files would be imported. So in the build system, I can just calculate it on the fly and it would work all out. And it's Haskell, so I can just write in my Haskell code the code for the build system, which is nice. Okay, and then we get to the class system. We have the tool class, which is the basic encapsulated command line class program. It has a name, which program it uses. You can invoke and some functions to actually make default invoke work, so you know how to convert flags and arguments to for that particular program the correct representation, because representation of how a flag should be represented is different between programs. Okay, now we have the output tool, is just basically let the tool class know about locations, which is useful when we get to the preprocessor class. It's actually a double abstraction, as it uses minimal batch preprocessing, which was used inside the package description file, where you explicitly say which is the input file, which is the output file, and which flags to use. And an automatic preprocessing system, where it describes how, when I want this file, which files are needed, which files are needed to build it, how that files are built. That's used for a compiler where we normally only specify I want the executable or I want the library. I don't care which other files or how they should be built. That's described in okay. So preprocessor for the manual and the other functions are a lot of complicated stuff for the description. Okay, then we have the compiler. It's basically a preprocessing. Every step happens in the preprocessor class, but the compiler knows about packages, which the preprocessor normally doesn't. So it's another abstraction, and it's just installation directory, where should I find packages, where do I install them, and so on. Okay, shape. What basically does is basically the rule, I have a target, which file I want to build, and how I want to build. And need is kind of, these are my dependencies. What it will do is it will lock on need until my dependencies are met, and then it will build the rest. Okay, the preprocessor class is pretty simple. You just need a source, you code the file with text apply. Compiler rule is slightly different because first I get the direct dependencies, which to an object file is the Haskell file, and indirect are the interface files of the import. This last code is slightly compressed to make it fit the file because I had to make sure imports which don't refer to local files but refer to for package files that they don't end up in build rules, because then we'll just complain, I can't find that file locally, which is exactly what we want. Okay. Preprocessing, how that's now done. It's just written in the code package description. Okay, I have a plugin system, which is completely, there is just a generic class instance of plugin for all the 4 class instructions I have, which basically just passes all the functions, passes it on to an external program, which is the actual plugin. You basically define a plugin by just writing the instance you want and make the main preprocessor plugin. This preprocessor. This is very simple preprocessor, which basically just copies the file. The plugin system, yes, I'm not particularly sure it's a really good thing because it has a lot of I/O overhead, but it allows Cabal to exist completely independent of which compilers, preprocessors are present and you want to use. You don't have to recompile Cabal anytime a new compiler is added or a new preprocessor is added. So it's extensional in preprocessors. Okay, the multiple targets. It turned out to be pretty trivially. Just write more rules for shape, and it will happily build all of the targets for you. What I also did is sharing the same generated files for an executable library. You normally use the same object files anyway. So just don't redo that compilation of the object files. It can be turned off if it turns out to be a problem, but I have not found any problem with that. And of course, there are some naming clashes, but that the instance, the preprocessor instance, should be defined in such a way there will not be any, or just forbid the target to be built. Okay, this is an experiment, so there is a long list of future work to be done, and this is even a small sample of it. But what I really would like is to hook it into the rest of Cabal, because the rest of Cabal is actually, it works fine, but from user, so we have user Haskell compiler, which has multiple targets, user attribute grammar system, which doesn't really fit well into the current package description format. But also, the package description format of Cabal is much more elaborate than my simplified version because I want to focus on what I want to do instead of all the complex stuff. But it would be nice if that is added or somewhere integrated into each other, so it would be a lot more useful that way, because at the moment I can only build for, well, at the moment it's only really usable for DSC, because USAC had some bugs which are only fixed this week. So I will be fixing that with USC support is there. And even when it isn't useful, I hope at least to have two main contributions, which is a generic interface to work with external programs, which is totally independent of whatever you want to do with Cabal, and a shape based build system for Haskell, which, as far as I know, haven't been done generically for Haskell. And as I said, it's only a bad version. And all the source code is at GitHub, and I hope to by next week it will be also available on Hackett. Okay.
In this problem Cabal has of building packages for profiling that use type with Haskell?
Building packages for profiling?
You know, you have to configure ones without profiling build, configure again with profiling build.
Yes, but actually I can do that in one go.
Okay.
With compiler target bytecode, which is my basic instance, and then just flavor plain and flavor profiling, and then we'll build both at the same time. But one, it doesn't build dependent packages, it just assumes dependent packages are there. And there's no way of doing versioning for the packages.
How easy do you think this would be to adapt to language whose compiler is written in Haskell but is not Haskell?
Well, the compiler, I think it's pretty straightforward. There's the only part where I saw dependent on that's actually used for Haskell programming is in the default values I supply. So the default compiler is DHC. But for the rest, I think it should be portable to any other compiler or preprocessor for any other language. I tried my best to make it Haskell independent, even though you need Haskell to actually build it. But okay.
So you said that you had only re-implemented the Cabal build system.
Yes.
So this is like the Cabal library as opposed to the Cabal install executable.
Well, I built also the executable,
but it's like the setup script that you can build for building your Cabal project, as opposed to
no, it's
dependency resolution.
That I don't do.
Right.
Dependency resolution.
So can you build multiple packages at the same time?
No, I just can only build the package it's in local directory. Just like Cabal build. You only build that package. And that I just assume all packages are present, all dependent packages are present.
Okay, and how does so when you say you assume all dependent packages are present, how does the configure step work?
Well, I actually merged configure and build. So it's only one. So the configure would be the type of which compiler targets, right? It's only configuring I allow at the moment. I can specify for which targets and which backends, which flavors to build.
Okay, but you can't say use this dependency from the package base.
Well, here you can specify. Here, you have packages where you can specify which package to use. You can have anything that can be passed on directly to GHC, so you can write versioning there, but then I assume that version is present locally.
Okay.
No more questions.
Just one quick comment. So we also have internally a shake-based build system for compiling Haskell programs. So maybe we can just talk later on. So.
Yeah.